Hello, today we have a mystery computer that we can connect to using SSH. So it's running the SSH server. We can connect using an SSH client. And these are the three pieces of information that we have. So we have an IPv4 address of the SSH server, username and password. So let's connect. Use the SSH client. The syntax is SSH space username at the IPv4 address. Okay, it says you never connected to this computer before. Are you sure this is the correct computer that you really want to connect to? Yes. And then it asks for the password. So we go plain text password. And I messed it up. Okay. Plain text. Okay, and now we're in. We immediately find out the name of the operating system because it's printing in the MOTD in here, but let's pretend we do not know. So what can we do? Well, first of all, we need to know the operating system that's running here. So there are exotic operating systems that might have an SSH server, but you're not likely to encounter them, such as Windows or I know some previous version of the Unix operating system, such as Solaris, Open Solaris. The possibility is here that there's also a slim chance that's a macOS server, SSH server, so a macOS machine, and the biggest chance is that this is a Linux machine or one of the BSDs. Okay, the very first thing that we do, let's go uname. Okay, so uname is part of the minimal userland of the Unix operating system. So all of the operating systems that tend to be Unix compatible, have a degree of Unix compatibility or POSIX compatibility, will have a certain number of executables available at your disposal. So one of them is uname. And let's find the command line for uname. Man is the manual page searcher and viewer. Okay, so it says -a is print all of the information. And we can see it's GNU core utils. So this is very likely to be GNU/Linux. Very likely. Okay, uname -a. Okay, so we can see it's Linux kernel. Yeah, so it's GNU Linux. Then the version of the Unix kernel is this thing. Okay, SMP means that it knows more than one CPU. So how many CPUs do we have? Since we're on GNU Linux, we already know a ton of stuff about this operating system. So we probably have nproc. It says 12. Print the number of installed processors. Exclude part of GNU core utils. Okay. Another way of getting at the list of CPUs is proc CPU info. Okay, so processor count 11, so that means this is the 12th processor. Processor index 10, so this is the 11th, etc., because the first one is at index 0. Let's go there. So the first processor, this is one of the processors, and this is the processor with index 0, so the first one. And then the second one, all of the processors are in fact identical. Okay, so we know the CPU. We know it's 64-bit because it says in here, in the kernel that's running on this hardware. Okay. What else? The other hardware that's interesting for us is the random access memory. So that's free. Says no swap partition or swap file, because swap total is 0. And then memory is almost 5 gigabytes total. So hardware RAM size 5 gigabytes. You don't really find computers that actually have 5 gigabytes of RAM and not this strange number. So this is probably a virtual machine. Okay. And then this thing probably doesn't have 12 cores. So it has 8 cores and 16 threads. So again, it smells like a virtual machine because it has allocated just 12 vCPUs, so virtual CPUs, out of the possible 16. Okay. What else can we do? We have DU, like this, DF. Okay, -H for human readable. Report file system disk space usage. GNU version of DF. Where is the lowercase h? H. So human readable print sizes in human readable format. So this will switch between kilobytes, megabytes, gigabytes as needed, such that it uses the most appropriate of the possible units of measurement. Okay, so DF, we know that there's a slash, which is dev VDA1. Okay, VDA means vert.io. So the where are you? Storage is SSD vert.io. Okay, available 20. The size is 25 gigabytes, and 1 gigabyte is used out of those. Okay, all of these directories, partitions, file systems that have the same size, 2.4 gigabytes, are backed by the same thing, and these others the same. So they're Linux kernel file systems. Dev TMPFS, 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 and TMPFS. Okay, and then TMPFS is more. So we know that there is a slash, which is the root of the file system. It looks like this, and it has 24 gigabytes free, and we can see that the directory /bin is in fact a symlink to /usr/bin, which means merged USR. Okay. So /sbin points to /usr/sbin, /lib64 points to /usr/lib64, and /lib points to /usr/lib. Okay. What's my name? ec2-user. I can see it in here. So this is called the prompt, this part here. And this prompt seems really familiar to me, so it screams bash at me, born again shell. So let's put the username. Okay. Where am I? pwd. I'm in the home directory of my user, my Linux user. Okay. Let's see if there's PS3. Yes, there is. So a really small amount of processes. There's no X server running. That's why the amount of processes is really small. So this virtual machine operating system has started in non-graphical user interface mode. So in text mode, we can see that the init is systemd. So let's write that down. So PID1 is a special process, is the first process that the kernel space Linux kernel starts after it finishes loading the RAM disk and etc. So it starts systemd, which is the equivalent of the init process. Okay. And then there's a ton of these processes with square parentheses, which PS3 ignores. Okay. So let's look at what PS3 shows. So it shows anacron, which is a cron, which is a scheduler, runs scheduled tasks whenever needed. ATD, the same thing. This is for TTIs, TTYs. Okay, for teletypes, for connecting to the machine. auditd, I have no idea what it is. cronid smells again as a scheduling daemon. crond again smells as a scheduling daemon. dbus, this is for inter-process communication. So various processes communicate using dbus. Okay, GSS, I know this thing was for single sign-on. Okay, then there's the login, bash, sudo, su, and then bash. So this tells us that locally on the hardware machine, on the virtualization software in this case, there's a user that's actually connected to the virtual machine. Okay. This thing LVM, probably from the volume manager. These things, I do not know why they are. rngd random number generator daemon, something like that, rpc bind another interprocess communication daemon server, maybe thought to be used for connecting using NFS, network file system. rsyslogd, this is the one of the logging daemons. So when you want to write something from your process and you want that thing to be persisted, you might send that to rsyslogd or to this other one, which is systemd journal. Okay, then systemd has spawned the service called sshd, which has started the process sshd, which we've used. We're inside of bash, so this thing that has written in here. And then there's ps3, the current process. When ps3 actually writes things to standard output, ps3 is still alive. But then ps3 dies in here when bash takes over control and has written the prompt again. Okay, udevd is for devices, so if you plug in a USB stick, that will be picked up, and hardware hot plug will do its thing. And systemd login, I do not know what it is. Okay, so we know quite a bit about this operating system. Seems to be pretty modern because systemd is pretty modern. But then this number seems really, really old. So let's see what this kernel version actually is. So it says 4.14.301 was released in December 8th last year, so 2 months ago. December, January, February, so pretty new. But it's a older branch of the Linux kernel, but which is still being maintained by Greg Kroah-Hartman. Okay, so the kernel again has been branched a number of years ago, but still gets security updates. So it's not insecure, it's just not, it doesn't have the latest and greatest features. Okay, what else can we do? So are we inside bash? Yes, we can see we're inside bash because this. So the father of the process ps3 is bash, and the father of the process bash is sshd, and their father is systemd. Okay, so this is called a process tree because the father of everyone, which is the Linux kernel, has spawned systemd, and then that has spawned this list of processes, and so on, so on. If I kill the process systemd, all of the processes will die. If I kill the process sshd, bash will die. Okay, how do I exit this bash? For instance, I can go Ctrl-D, and now this thing has died, and this thing has died also. So only this, and this are still alive. Let's connect back using SSH. Okay, so it says Amazon Linux 2 AMI, whatever is that. Also have a URL. Okay. So this is the default operating system in Amazon's cloud, in Amazon Web Services. This is one of the most used operating systems there, and one which is sometimes the default solution. Okay, yeah, maybe Ubuntu LTS operating systems are used way more often in Amazon Web Services EC2 instances that are running, but still Amazon Linux is the offering from Amazon. High performance execution environment to develop and run cloud applications. Doesn't cost anything, and it's maintained and updated with security updates by Amazon Web Services. Okay, but doesn't really say what's its lineage. Let's use Wikipedia. So Amazon has its own Linux distribution that it's largely binary compatible with Red Hat Enterprise Linux. Okay, so let's copy this thing also. Offering has been in production since September 2011. So this is Amazon Linux Not 2. Okay, Amazon Linux 2 changed from System V init to System D, announced in June 2018. And yeah, it still uses the same Linux kernel 4.14. Okay, let's look at the Red Hat Enterprise Linux history and see which of its versions use kernel 4.14. So there's versions 7, 8, 9, 7.9, 8.7, 9.1. Okay. Can we search for 4.14? So Red Hat Enterprise Linux 9, when it debuted, used the kernel 5.14. Red Hat Enterprise Linux 8, when it debuted, has used the Linux kernel 4.14, 4.18. Okay, and Red Hat Enterprise Linux 7 has used 3.10. So it's strange. So it's something between Red Hat Enterprise Linux 7, which uses 3.10, and Red Hat Enterprise Linux 8, which uses 4.18, not 4.14. Both 7 and 8 have used systemd. Okay, let's look at the distro watch. Let's see what it says. How do we get to... So it doesn't have in here the Amazon Linux. Okay, Instead of guessing which version of Red Hat Enterprise Linux a particular distro is based on, just run rpm -e% and then hell. Let's do that. So it says version 7. Okay, and then there's this file etc/os-release. Let's look. Amazon Linux 2, like CentOS, like Red Hat Enterprise Linux, like Fedora. Okay, so we know enough to know that the package manager, so the binary packages, will have the extension rpm, and probably the package manager is either yum or dnf. So let's find dnf there. No dnf. Let's find yum. So yum exists. List a package of group of packages. Okay. So says could not retrieve mirror list Amazon Linux.default.amazon aws.com because could not resolve host Amazon Linux default.amazon aws.com. So it might be that the repository, the server that hosts the rpm yum repository, is only available inside of Amazon Web Services Cloud. Let's see. Access denied. So it exists, but it's not allowed. Okay, so without that, we cannot probably install packages. Okay. So since we're in bash, we can investigate all of the environment variables. Let's set. Let's use a pager. We're in Red Hat Enterprise Linux, so less will work. Otherwise, we need to paginate using more. Okay, so it's bash. Path is the usual one, so /usr/local/bin, /usr/bin, sbin, and then tilde/.local/bin and tilde/bin. Okay, shell bin bash. We're connected using SSH. Okay, let's list all of the executables. Tab. No, doesn't want to do that. A. How do we list all of the executables? USR bin. Okay, so there's the usual Unix userland, so square parentheses, addr2 line, alias, apropos, r, at awk bash or whatever shell later on sh. Zippers, bzcat, bnzip, all of these busy ones. Cat for listing the content of a file, cd for changing directories, okay, chmod for making files executable or changing their owner or group, chown, cpio for rpm, the package format, a C compatible shell, the tool that can download anything, date, basic Unix executable, dir probably does the same thing as ls, dmask for the log, du disk usage, a non-interactive editor, force, foreground and background, free shows how much free RAM and swap do we have, awk, the GNU awk. So there's no compilers, no GCC, no GDB, the debugger, GIO, this is from the GTK library, GPG for digital signatures, grab the bootloader, zip, compression format, gzip, spell checker, Lua, a programming language, lists directories, ls, creates symlinks, ln, ldd shows what shared libraries are loaded by a executable or by another shared library. Something about JSON, kill and kill all to kill processes for kernel modules, who connected last, what else? LZ, the compression format LZ, man manual pages, make for compiling things, mount, this is needed because in Amazon Web Services you can add to EC2 instances other types of storage when 25 gigabytes is not enough for you. Message format, this is GNU's internationalization library. Nano, a text editor, moves files around or directories. Netstat for network debugging. Ping for network debugging, ping version 6 for network debugging. know how to not kill a process when the SSH connection stops working. And proc says just 12, which is the number of n CPUs, of virtual CPUs. Okay, so these are for object files, for files with extension.o, OpenSSL, for encryption and hashing. Perl is available in most operating systems by default in the very base install. Package config for determining which package has been built with which C++ command line, which C libraries, etc. So how a software has been compiled. This is the splash screen when the computer boots. Okay, this lists the processes. This lists the processes as a tree. Says the current directory, in which directory we're currently. Then Python 2.7. Very, very outdated. End of life. Very nice for making processes take more or less CPU resources. RM for deleting files or directories. RMDIR, the same thing. RPM. This is probably restructured text to various other formats. Rsync to synchronize between two directories, only copying the files that have changed or are new. Screen, really good. After you connect using SSH in your process tree, SSH will be the father of all of your processes. So when the SSH connection closes, all of your processes will die. So what you do, you use, after you connect using SSH, you start screen, and then all of the processes that are children of screen will never die when the SSH connection times out, or when maybe your network connectivity, so when the SSH client disconnects from the SSH server because of network connectivity issues. Screen will continue to survive and have a tree of children processes. Sed minimal Unix userland. SFTP and SCP for copying files remotely using SSH protocol. The sums, SHAs and MD5s. Shred for deleting hard disks correctly. Shuf for reordering the lines in a file randomly. Sort orders line in a file. SQLite 3, the file-based database. Okay, the SSH client. strace for seeing which process does what. Strings, what UTF-8 strings exist inside of ELF file, which is the native binary format in Linux. Strip to remove debug symbols from executables or from binary files. Sudo to become superuser, su to become superuser, systemd and systemctl. So systemctl for restarting services, for seeing which service is running, for disabling a service. Okay. Tar for compressing and uncompressing, C shell, D receives something via standard input, and then it sends that thing to two places, to a file and to its standard output. So it's a three-way intersection. The T is in the uppercase T. Test part of bash, part of the Bourne shell, Unix minimal userland. Time the same thing. Time the HCTL part of systemd. Touch creates empty files. Trace route for debugging networking issues. True part of the shell. Time zone. A udev, the hot plug hardware. Umount for unmounting. Uname the first thing that we run, so we run uname without any parameters, and then we run uname space -a. So it shows some details about the running operating system. Okay, LZ4, XZ, zip, compression formats. Uptime, when was the computer last started? Update DB, command line, framework for searching for the files that exist on the hard disk. Fast, but incorrect. Okay. What else? VI and Vim, the most complex text user interface terminal editor, interactive one. Word count, wget downloads files from a variety of protocols such as FTP or HTTPS. Who says who's connected to the machine, who am I, my name. Which says where is a file located, if it's executable, and part of the path environment variable, its directory. Xargs, part of the minimal Unix userland. XZ for compression, these things. YAM, the framework that runs on top of RPM. So RPM is the low-level package manager. YAM is the framework on top of the another package managing framework on top of the RPM database and executable. Z compression, all of these things. Okay, so this is a minimal Linux operating system that's made to run at the command line, and this makes it then possible to install many other things in here. So you could install Git, a C++ compiler, GCC, G++, and then you could add additional software. Or if you have access to the repositories where YAM has the list of available packages and where YAM can download packages from, RPM packages, then you can install native packages for this Linux distribution. Okay, so yum is the high-level package manager and RPM is the low-level one. This thing. Okay. So editing the file system, there's cd to change directory, rm to delete a file, move to move a file or directory, rmdir to delete a directory, dir an alias for cd, dir a alias for ls. Okay. ls lists the files in the current directory. All of the files in the current directory, so my home directory, are hidden, start with a dot. So that's why when you call it without any parameter, you just call ls, it will not show anything. But if you say show me all of the hidden files, which means ls space -a, it will show all of the hidden files, all the files that start with dot from the current directory. So that's 4 files and 1 directory. And -l means long format. So show each file or directory in one line. Okay, so we know something about the hard disk, we know about RAM, we know about the CPU. What else? We didn't see any other niceties like LSHW, LSHUL, the LSBLK. Yeah, it has LSBLK. Let's look a second at LS. So there's ls for listing files, list hard disks, CPUs, okay. So it says when the hardware, the Linux kernel has been compiled on December 9th, 2022. So as we saw in the release notes. Okay. Of this Linux kernel version. Okay, so which ls returned /usr/bin/ls listing, and then LDD has seen that this file is in fact a binary, a Linux ELF file. So it's an ELF file, 64-bit, x86-64, dynamically linked, uses shared libraries, and does not have debug symbols, because Amazon wants, the AWS wants that this operating system is as lightweight as possible. So installed, it only takes 1.2 gigabytes. Okay, so 1.2 gigabytes used in the slash partition. These things are virtual, so don't really exist on the hard disk. So it's a really small base on which you can create cloud HTTPS servers or other servers, Node.js, bring your programming language framework of choice. So this is it. Thank you.